Welcome to this example, which is an example of using superposition to find voltages and currents in a circuit with a dependent source. So the goal of our exercise here is to find Ix and Vx in the circuit below. When we're applying superposition, the thing hopefully that you remember is that we will find the output Vx and Ix due to each of the independent sources by setting the other independent source to 0. Now when we do this, we don't set the current sources to 0. So we would find Vx is equal to Vx prime, which we might think of as the response due to the 1 volt source with the 4 volt source set to 0, plus Vx double prime, which is the response due to the 4 volt source with the 1 volt source set to 0. Similarly, Ix will be the sum of Ix prime plus Ix double prime. Okay, so with that introduction, let's go ahead and solve for Vx prime and Ix prime. So we'll bring up a clean copy of the circuit. Again, we will find the response due to this 1 volt source, and so in this case this will be Ix prime, this will be Vx prime. Now one thing that sometimes isn't clear is when we're solving due to one source and we have a dependent source, the dependent source is dependent on the voltage in this circuit alone and not in the circuit with both sources. Now to make this what we need, we actually have to also get rid of the voltage source, the 4 volt source, and replace it by just a short circuit. So now we have the circuit that we need to solve for. So looking at this, how do we want to do this? There's a couple of different approaches we could take. It looks to me like what we'll probably have to do is apply Kirchhoff's current law to this top node. That will allow us to find currents and such. And we'll have to assume, we'll have to leave Vx prime as an unknown and get one or more equations for it, and then solve for those equations to be able to figure out what it is. So I guess if we're applying Kirchhoff's current law, we can say that the current exiting through the 6 ohm resistor, exiting the top node through the 6 ohm resistor, would be Vx prime, that's the voltage from the top node to the bottom node, divided by 6 ohms. Okay, so that gives us one current. We know that this current going through the current source is 2 times Vx prime. We know that Ix prime here is equal to Vx prime over 3 ohms. And so now we just need to find the current that goes in to the top node through this resistor. And this current would be the voltage difference across the resistor, which would be 1 volt minus Vx prime over 2 ohms. So we know the currents. We can now use Kirchhoff's current law to say that the sum of currents entering the node is equal to the sum of the currents leaving the node. So we have 1 volt minus Vx prime over 2 ohms is equal to Vx prime over 3 ohms plus 2 Vx prime plus Vx prime over 6 ohms. And we can basically solve this for one. We can move all of the Vx primes over to one side of the equation, and we get 1 volt over 2 ohms is equal to Vx prime over 2 ohms plus Vx prime over 3 ohms plus 2Vx prime plus Vx prime over 6 ohms. And we can factor out a Vx prime to say that this is equal to Vx prime 1 over 2 ohms plus 1 over 3 ohms plus 2 plus 1 over 6 ohms. And we know that this is equal to 1 volt over 2 ohms. So now we can basically just work the math. Plug this into our handy calculator. And we have 1/2 divided by 1/2 plus 1/3 plus 2 plus 1/6. And doing that, we get then that Vx prime is equal to 0.1667 volts. Okay, so the next thing on the agenda is to go back to our original. I guess the very next thing on the agenda is to note that Ix prime, which is Vx prime over 3 ohms, which is equal to 0.055 amps. Okay, so now I've got everything I need from the 1 volt source. So I go back to my original window. We note that Vx prime was 0.1667 volts. Ix prime is 0.0555 amps. Okay, so the next thing to do then is to eliminate the 1 volt source and find out what Vx double prime and Ix double prime from the 4 volt source is. So let's bring up a clean copy, cut out the 1 volt source. Note that this is Ix double prime, Vx double prime, and Vx double prime. And it looks to me like, again, probably the easiest way to solve this is to apply KCL at the top node. And so we have the current going through the 2 ohm resistor will be Vx double prime over 2 ohms. The current going through the 3 ohm resistor, which is Ix double prime, will be Vx double prime over 3 ohms. And the current going through the 6 ohm resistor will be the voltage across that 6 ohm resistor, which is, we'll bring this up here, Vx double prime minus 6 volts, or I'm sorry, that shouldn't be minus 6 volts, minus 4 volts over 6 ohms. And so now we can basically say then that the sum of all the currents leaving the node is 0, so we have Vx over 2 ohms plus V, and that should be Vx double prime, Vx double prime over 3 ohms plus 2 Vx double prime plus Vx double prime minus 4 volts over 6 ohms. And this is equal to 0. So we can simplify this a little bit by moving the 4 volts over 6 ohms over to the other side and factoring out a Vx double prime. So we get Vx double prime 1 over 2 ohms plus 1 over 3 ohms plus 2 plus 1 over 6 ohms is equal to 4 volts over 6 ohms. And with this then we can solve for Vx double prime. And if I've done this correctly, Vx double prime should be 2/9 volts. Okay, which means that Ix double prime is going to be 2/9 volts divided by 3 ohms, so it's going to be 2/27 amps. And I can figure out what that is numerically. Whoops, I don't know what happened there. So this will be 0.074 amps. And this guy will be 0.2222 volts. Okay, so we go back to our original circuit. We have that Vx double prime is 0.2222 volts. Ix double prime is 0.0741 amps. Okay, so now we can just add Vx prime and Vx double prime. We get then that Vx .3889 volts, and Ix is going to be the sum of Ix prime and Ix double prime, which I'd better work out with the calculator because I don't expect to do this one in my head. So this is 0.1296 amps. And there you have it. This is an example of having worked this circuit to find Vx and Ix using superposition. Again, the only potentially tricky part of this is when we use superposition, we zero out all but one independent source. We never zero out dependent sources. So you need to remember that as you're doing, or as you're applying superposition. You never zero out the dependent sources. You always have to solve the circuits with those in them. So hopefully you found this useful and entertaining, and we'll see you later.